Did she already? I didn't remember that.
I'm vaguely remembering.
Okay. So this is why product rule is necessary, because there are problems that you need to combine product and chain. Like the ones I gave you guys last time for product rule, like I told you, I probably wouldn't even do those with product rule. It just wasn't necessary. But now, it is. So, I've got a bunch of stuff going on here. I've got a function with an x in it, times a function with an x in it. So this is like, if you want to think about like your f and your g. So this is product rule. So I'm going to take the second thing and multiply it by the derivative of the first thing. But when I go to do the derivative of the first thing, what rule am I going to have to use? I'm going to have to use chain. Plus, the first thing times the derivative of the second thing. And when I go to do the derivative of the second thing, use chain rule again. So I'm doing both the rules here. So, and then I think the harder part for most people is like what to do after that. Like, there's certain ways I'm going to ask you to simplify them and put things together. Alright, so the second thing. Product rule says you write down the second thing just like it is. And you multiply it by the derivative of the first thing. Well, the derivative of the first thing is a chain rule problem. What's the big guy here? The third power. So you always take the derivative of the big guy first. So I bring it down. The power rule says you bring it down, reduce the power by 1. What do I do with Mr. Packer? Leave him alone. And then I multiply by the derivative of the little guy. So this is my 2, this is my D1. So I'm rewriting the second one, I'm taking the derivative of the first thing, but I have to use chain rule when I do it. This 3, I didn't mean to make these both 3's, but this 3 is because you brought the power down, this 3 is for the derivative of the inside. Alright, repeat it, but flip it. So the second times the derivative of the first plus the first, so I rewrite the first one just like it is, times the derivative of the second. Well, the second's a chain rule also. What's your outside function there? Fourth power. So to take the derivative of powers, you bring them down and reduce by 1. So that's me taking the derivative of the big guy. You leave the little guy alone. Then you multiply by the derivative of the inside. So this is your 1 and your D2. Questions there? Let's just combine the two rules. So then the simplification rules are going to be, you have to get this down to 1 term. If there's fractions, you got to get a common, which we'll get to in a couple examples. You got to get the 2 fractions to a common denominator and add those 2 fractions up. So there's only 1 fraction. And if there's a situation like this is 2 terms because you got this giant plus sign separating 2 things. You got to get that to 1 term. So what we're going to do is factor out common chunks. Always going to be common chunks because of the way product rule works. So if I look, in this term over here, how many x squared minus 5s are there? 4 of them, right? How many x squared minus 5s over there? 3 of them. So I can take 3 of them and put them out in front. I'm going to do the same thing with the 3x plus 4s, and then I'll talk about what happens after that in a second. So how many 3x plus 4s can I take? I can take 2, right? I got 2 here and 3 there, so I can take 2 of them and put them out in front. Well, in this term, I just took 3 of these and put them out in front, so how many are really left? Just 1. And I took 2 of those and put them out in front, so isn't that really not there anymore? It's out. It's still there. It's just out in front instead of being written in here. So it's just a distributive property in reverse. And then what's remaining is x squared minus 5 times 9. Questions on what I'm doing there? So do the same thing with the second part. And then I'll talk through again, like just to remind you what reverse distributive is and stuff. So if I took 3x squared minus 5's away from this term and put them in front, they're no longer even in that term. I took 2 of that 3x plus 4's and put them in front. Now there's only 1 there. So what's remaining here is 3x plus 4 times 8x. And if I were to distribute now, if I took this and multiplied it by this x squared minus 5 times 9, wouldn't I get all this? And if I took this and distributed to here, I would get all that. So that's what we're doing. We're just distributing them backwards. And now I have one term. I'm not done simplifying yet, but I have one term. It's all just one giant multiplication problem. There's a reason for that. We don't get to that reason for probably a month or so, but there is a reason for it. I'm not just making it up out of nowhere. Questions up to there. The hard part's done. Not that it was simple, but what can I answer? Where'd you get this? Why'd this happen? Thanks for stopping by. Okay. Now I just got to clean up the inside. This is just like a simple algebra thing. So I'd have 9x squared minus 45 plus 24x squared plus 32x. So my last step is just cleaning up that middle part a little bit. So that would be 33x squared plus 32x minus 45. And that's one term. That is all one big multiplication thing. And I can tell you the reason now, I guess. Eventually, we're going to set this equal to 0. We're not yet, but set this equal to 0 and solve it. And then you'll have your chunks already set, your factors, and you can take each factor separately and set them equal to 0. When we're setting them equal to 0, they won't be this complicated typically. But I'm just trying to set up the pattern. So we're kind of doing the same process. So what can I go over there? Where'd you get this? Why'd you do this? What the hell is happening? Anything I got that last comment. But is there like a specific what the hell is happening I can help with? And just keep doing more. Like, is that?
It's one of those like follow-up I'm going to have to do them. So
Yeah, for sure. For sure. So let's do another one?
yes.
Okay. Alright, let's say y equals so just so you know what's coming, then we get into what if the exponents are negative and or fractions. So believe it or not, this is still like the easier ones. They're not that bad. You guys get used to them. See? It just looks overwhelming at first. So first of all, this is a product rule, right? I got a thing with an x times a thing with an x, and within that product rule, I'm going to have two chains. Same as last one, right? So I'm going to write down the second thing. And I'm going to multiply by the derivative of the first thing. So, if I just gave you x squared minus 8 to the 5th and said take the derivative, that's chain rule. So you bring down the 5, reduce the power by 1. What do you do with the little guy? Leave it alone, and then you multiply by derivative of the little guy, so 2x. And so that's my second thing times the derivative of the first thing. questions there? Okay. Plus the first thing. That's just rewriting the first thing. Times the derivative of the second thing. Well, the derivative of the second thing is like its own chain rule. So I'm bringing down the 3. Reducing the power by 1, and I'm multiplying by the derivative of the inside. So that's the calculus. Like the calculus is over. We made it. All the way to the second step. What can the hard part's the algebra, right? Like the hard part's after that. I think. Yeah.
So the D1 and D2, that's where you use the chain rule?
Yes. So when I go to take the derivative of that first piece, I look at it, I'm like, oh, this first piece is chain rule. So like within the product rule, I'm using chain rule. All right. We okay so far? So now I gotta get this down to one fraction. I gotta like reverse distribute. So maybe I should do like an easier example. Let's say if I had, I don't know, x to the 4th, y to the 3rd plus x squared y to the 4th, and I wanted to reverse distribute that. This is just like I'm trying to like break it down a little bit. How many x's could I take out in front? 2 of them. How many y's? 3. And if I did that, if I took 2 x's from there, there'd be 2 left. If I took 3 y's from there, there'd be none left. If I took 2 x's from there, there'd be none left. 3 y's from there, there'd be y to the 1st. And what I'm trying to do is just pull them out like that. So now if I distribute it here, what would I end up with? The thing I started with, right? That's all I'm trying to do. I'm just doing it on a much larger scale. So, how many 2x minus 3's can I yank out in front? 2 of them. How many x squared minus 8's? 4 of them. So then those are out in front. They're not like in there anymore. So now I pulled 2 of those away. There's only 1 left. I pulled 4 of those away. So they're gone. I mean, they're not gone. They're just out here now. I took 4 of those away, so there's just 1 left. I took 2 of those away, so they're not there anymore. And then you write what is remaining, like in the big brackets inside. So this would be 2x minus 3 times, I'm going to put 10x. I'm going to like combine these two. And say, okay, that's just 10x. Just save myself a step down the road. Plus x squared minus 8, and then I'm just going to put times 6. With me there? Is this seeming less overwhelming now? Get by the second time. Slightly. Okay, where can I mean, the last step is not hard at all. So up until here is the meat of the problem. What can I do? What can I help with? You just got to practice. Yeah. Okay. So then we're doing the inside. So, this is 20x squared minus 30x. This is 6x squared minus 48. So I'm just simplifying inside. It's like I cleaned up the giant mess, now I just got to clean up the little stuff that's left over. So this would be 26x squared minus 30x minus 48. And you do not have to take this next step, but they might on a multiple choice, and I want to make sure that you can tell it's the same thing. Or they might on like the answers on the computer printout thing. What did I do there? I just took out a 2, right? So when I got down to this stuff in here, I was like, oh, those are all even. So now here's the 2. If I multiplied it through all those, I'd end up with all those. And you don't have to do that, but they might on the multiple choice, and you got to be able to match up with what they're doing, Everybody work ahead of me, and you got to, so you got to hear before I did? Cool. Questions? Anything in there I can Where'd you get that? Why is this number here? Okay. Alright, let me give you guys one and I'll shut up. You guys try to do it without me rambling up here. Really easy to forget. Like, there's just lots of chances to screw up. So eventually you're almost bound to stumble into one of them. But it's really easy to forget. Like when you do the chain rule, the common mistakes I see is you'll bring down, like for example here, you bring down the 4 and you just forget to write the power there. So make sure you reduce the power by 1, not like forgetting it exists. Or you'll forget to write the 8x there, like you forget about the chain. And you all know chain rule. Just gotta forget that that's supposed to go there because you got all this other mess going on. So bring down the 6, make sure you reduce the power by 1 to get it to a 5. Make sure you still write the 5 there, and then you get the 3, so it's the times the derivative of the inside part. I'll shut up again. Keep working. Just getting you the first step so you can check it. Alright, so I'm going to look at, I can take 3x plus 5 out. I can take 5 of them. And the 4x squared minus 3, I can take 3 of them. So now there's only one of those. Those are gone. There's only one of those. And those are gone. So I'm left with 3x plus 5 times, I'll just simplify that, call that 32x, plus 4x squared minus 3 times the 6 times 3 gives me 18. And that's the main part. Like, I still got to do the clean up little mess in here, but how many got to this part, let's say? Alright, questions on anything I can help with? And then we're just doing some algebra in here. 32 times 3, so 96 x squared plus 160x plus 18 times 4 would be 72x squared minus 54. So my last step would be this same stuff. Just write it over and over again. And then this will give me 168x squared plus 160x minus 54. Then you can start like simplifying this inside too. Alright, you can take like 2 out of all those at least. That might be it. I'm not too worried about that right now. How many got to that answer? Okay, so I mean you did like the majority of the problem. There's just so many chances to make mistakes. Like that's what it boils down to. Can you get through the problem without making a mistake? Yeah.
So, do you have to have the brackets around it? Can you put parentheses around that at the very end?
You can put parentheses at the very end. That was it. Yeah, the brackets just help me like organize it a little better, but that's up to you. Anything else? Alright, let's look at if there's negative exponents. You didn't think we were done, did you? You're ready for a packet? Oh, we're not. Not quite there. Let's just make them both negative. We're going crazy. They're both negative. I was going to ease you into it, but we're just jumping in. First step's the same deal. It's product. I didn't do anything yet. What?
I do the chain rule before I do the product rule. So like I label them as F and G. No wait, listen. I label them as F and G and then F prime and G prime. And I do the derivatives first and then plug it into chain rule so I don't do them like, or plug it into
product rule?
So I don't do them like at the same time.
I do the same thing.
Okay. That's fine. I thought you were saying, I don't even want to say what I think you're saying. So I don't want to confuse people. Okay. So you're just going off the side and you're like writing down what things are and then like putting them in?
Yeah.
Okay. So the only problem with that is that's why like you wanted more time and no one else did. And the AP test is timed, you know, so keep that in mind when you're doing them. It just takes longer. That's all I'm saying. It's just like writing it down again. Because I'm just writing it down here. You're writing it down here and then writing it down here, so it's just more writing. It's not like a huge deal, I'm just think about that one here.
It's just a slip.
But if you get it right, like a little bit extra time is worth it. You know? Okay. Alright, so 2d1 plus 1d2. So I'm writing down the second thing. Multiplying by the derivative of the first thing. So I'm bringing down the negative 4. Leaving the 3x plus 5 alone, reducing the power by 1, which makes it negative 5. And then I'm multiplying by the derivative of the inside. So again, that's my 2d1. Those are some ugly brackets there.
Is your game sold out for?
Yeah. frustrated.
No, I just wrote something.
Right.
Erasing takes time. I got to do it.
Okay.
Alright.
So plus 1d2. So we're doing the opposite. So 3x plus 5 to the negative 4. And then the second part is another chain rule. So again, this is like my 2 and then d1 plus 1 and then d2. That's the calculus. Calculus is done. The hard part is now we're not allowed to have negative exponents yet. You right? See the what? Okay. Okay. Oh, up here you mean?
Yeah.
I put it in like at the end, so I might have screwed you up. I was like, oh wait, let's make it there. Alright. So you're not allowed to have negative exponents. That's the first thing. So we gotta get rid of all those negative exponents. So how do we get rid of negative exponents? Put them at the bottom. And then the second thing is we can't have two terms. So what we're gonna end up with is two fractions. We can't have two fractions. So we're gonna have to get a common denominator, add up the two fractions, and get another fraction. Yeah.
Can we simplify it first like we did for the other ones and then cut it into a fraction?
You can. That's not the way I'm gonna show it today, but I can.
That seems cheaper in my mind.
I agree with that.
Because it seems like after you, I don't know how many denominators do. I've always struggled with so even with the more terms. It seems like it would be easier to.
So see, but
simplify.
my thought would be if you struggle with common denominators, you need to do it this way to practice it because it's coming down the road more and more.
Well, like
You're gonna have to know how to do common denominator stuff.
I know
Yeah.
how to do them. I just don't know how to do them.
It's up to you.
Okay.
Okay. So what I would do here is I'm gonna, I know I'm gonna have a fraction. These are gonna go at the bottom. So x squared minus 4 to the 5th. 3x plus 5, and now that's to the 5th. And then what's on the top of my fraction? Negative 12, basically, right? Leave some space here before you put your plus sign. We got some work to do in that space. And then same thing over here. I'm going to take the stuff with negative exponents and throw it to the bottom. And then what's left on the top is negative 10x, basically, right? Questions on getting to that stuff? That's just rewriting. So for common denominator, you have to have both of those be the same. So what I've got right now is 5 of these x squared minus 4s over here and 6 of them over there. So does it make sense to you that I need to put one more of them over here? So they'll both have 6. So I got x squared minus 4 to the 6th, I've got x squared minus 4 to the 5th. So I'm going to put one here. Because now how many do I have over here? 6, which matches. But if I put one on the bottom, I've also got to put one on the top. It's not that big a deal. You guys are acting like this. And then, so I've got the x squared minus 4 is like taken care of. 3x plus 5. I got 5 of them there. I've got 4 of them there. So how many more of them do I need over here? And it's always going to be 1. That's because the way that the derivatives work, you're reducing the power by 1. So you're always have to put one more. It's not ever going to be like I have to put 7/8 of them there or something. So I'm putting another 3x plus 5 down here, which means I need to put a 3x plus 5 up there. That's not that bad, right? I mean, there's a lot of chances to screw up. I get that, but I don't think it's like horrible. Now you just got to do some simplifying. So this would be negative 12x squared plus 48 over, now how many x squared minus 4s do I have? 6. you cancel out. Well, they have to be my answer though. You know, if I have like 2/3 plus 5/3 and 7/3, like the 3 stays. Is that what you meant? So distribute here. So it's negative 30x squared minus 50x over. We got 5 of the 3x plus 5s. The fact that I can make these in different colors, I think it's so helpful. Like that it's black, you can tell like what is yours different colors too.
That's why it's taking me so long to write it down, is because I'm switching colors every other term, basically.
Gotcha. And then you just add them up. So when you're adding fractions, like I was just saying, like 2/3 plus 5/3 is 7/3. The bottom just stays, right? So the bottom stays how it is. And the top, you're just adding up the common terms. So negative 42x squared minus 50x plus 48. And so again, what would they probably do here at the end on the top? Probably take a 2 out of that. You don't have to do that. You just have to be able to recognize in a multiple choice situation if they do that. That'd be what you get. Questions there? Seem decent enough? Reasonable? Before I erase that or not, like go to the next slide, anything else I could address on this one? Where this come from? Why this go on here? Alright, let me give you one. Try that. Just for funsies this weekend.
Yeah. I like that, so I would.
That's cool. I'm gonna write down like the first step so you can check that as you're going. When are you talking to me? Sorry to interrupt. So there's your first step. So you can kind of check and make sure that's good before you keep going. And that's the calculus. We've done calculus. You guys are. You got to that step. Calculus is not the hard part. Wait, I messed up.
Yeah.
This is not negative. I don't know why I randomly inserted a negative sign. Then it's positive here. That's exactly what I mean, though. Like, there's so many chances to make mistakes. Even just copying it. Okay, so that's correct, I believe. Questions on anything in there? Where did this come from? Why is this? That was thought at 28.
27.
So that's your next step. Just taking the negative exponents and putting them on the bottom. And then I like combine that and that. And that and that. There? How many are done already? You just gotta wait for me. Okay. So then, I do want to talk through the last part again, just to get in your brains again. 4x plus 7. I've got 4 of them there and 5 of them there. That means I need one more of them over here. So I'm just going to put one on the bottom, but if I put one on the bottom, I have to have one on top too. I'm going to multiply 18 times 7. Huh? Alright. 3x squared minus 1. I got 4 of them there and 3 of them there. So I need another 3x squared minus 1 there, which means I need one on the top also. And now my denominators are all set. So like I could even go down to the bottom now. And it gets annoying to rewrite it, I know, but it's going to be that plus the same denominator. And then in my answer, it's going to be the same denominator. So I got to worry about the top, just kind of cleaning up the algebra. So this is negative 72x squared minus 10 times 7 is 70, 8 times 7 is 57. So minus 126x. Yeah, that's right. And then over here is negative 48x squared plus 16. So I can just jump to the end now. How many x squareds do I have? Negative 120. Negative 126x. And 16. So do you guys see what I mean by skipping? Like that just goes there. That really just goes there, so I'll just add them up. Does that make sense? How many got to that answer? Nice. Questions? Okay. So we didn't get to any with fractions, which is fine. I didn't expect to get through everything today. So on here, let's look at it together for a second after I pass it out. calculus is giving you a headache?
This specific part of calculus. It's like trying to learn a new language.
All right, let's look at these together for a second. Quiet. Number one, we're gonna do it, so don't like cross it out, kill it. Just you don't have to do it right now. So you can put like a little slash. Like don't worry about that tonight or this weekend. Number two, this looks weird, but if we rewrite this, couldn't I rewrite this as 5x plus 4 to the 5th over 3x to the 3rd plus 5 to the 5th? And then couldn't I rewrite it like this to the negative 5th? So here's the thing. Chain rule and quotient rule together suck. If you have to do chain and quotient, you're in a bad spot. So we want to avoid chain and quotient whenever we can. So if I can get something so it's not a fraction anymore, I want to. So just make sure you follow what I did there. If the whole thing is to the 5th, that means the top and bottom are separately to the 5th. And then I'm going to bring that bottom one up. So I want you to do number 2, but starting from there. I didn't leave you very much room. You might need a separate sheet. So number 2 you have to do. Number 3 you do not yet. Number 4 you do not yet. Number 5 you do. 6 and 7 not yet. 8 and 9 not yet. And 10, let's look at rewriting that together. So if that exponent's negative, how do I get rid of that negativeness? I flip the inside. So that's going to look like that. Which means both of them separately are to the 5th. Which means if I want to get rid of the fraction, I can bring up that bottom part and make the exponent negative, right? So I do want you to do number 10, but start from that spot. So the ones we did on the board were harder than the ones that are on this worksheet. That might be slightly confusing when you do the ones on here because they're a little different. They're supposed to be easier. Like I was trying to do it at a harder level, but we'll see how it goes. So how many do you have?
3.
There's only 3 problems? That's fine. I'm okay with that. 2, 5, and 10, that's it? We'll get to the fraction stuff on Monday and keep going with this. It is not that bad.
Dude, I have to write it back someday. I went first he's collecting those. I'm just gonna write it.